Hello, welcome to the video. In this question, we're asked to calculate a slope, and we're not given a picture. Instead, we're given 2 points that the line is passing through. So we could graph these 2 points and calculate the slope by looking at the graph, but another way to do that is by using the slope formula. So let's write out our slope formula here. The slope formula tells us that one way to calculate the slope is to calculate y2 minus y1, that is my second y coordinate minus my first y coordinate, divided by my second x coordinate minus my first x coordinate. So this is kind of like the rise over run formula. Rise is talking about vertical change, and y's go on our vertical axis. Run talks about horizontal change, which is changes in the x-axis. But this can be a nice formula to use to then plug our values into. One thing to notice when we use this formula, the subscripts on the numbers don't mean to do any calculations. This 2 is just indicating my second y, my first y, my second x, and my first x. And another thing I like to do to really help myself out is to put parentheses around each of those. Those will help me keep track of my signs as I get started. So there's my formula. And now I'm going to write that formula again, leaving space for each of the numbers. So here's where my y2 will go. Here's where my y1 will go. There's my x2, and there's my x1. I've really found that beginning a problem by setting up in this way will save time and errors if we have a lot of negative signs to keep track of. The next thing I like to do is to go through for my points and decide, okay, which is going to be point 1 and which is going to be point 2. The answer will come out the same either way, but you need to make that decision so you can be consistent in your calculations. So let's call this my first point. Then this -7 will be x1, and this 2 will be y1. And then we can call this point over here my second point. So that -2, that's my second x, or x2, and the -6 will be my y2. Now as I go to my formula, the first thing I need to plug in is y2. So that is a -6. And while I'm at it, why don't I plug in my x2? That goes right underneath the y2, and that will be a -2. And now let's plug in those other values. I need a y1 in this position. My y1 is 2. My x1 is a -7. So now I have the values all plugged in. Now let's calculate it out. My numerator is looking like -6 minus -2, so you could do that, or sorry, -6 minus a 2. You could do that on a calculator. You could think about it by hand. I have a -6, and I'm getting rid of 2 more. Or I spent $6 and $6 in debt, and then I spent another $2, so now I'm $8 in debt. I have a -8 on top. For my denominator, notice we have a minus next to a negative sign, so I'd like to rewrite that as -2 plus 7 to really help me think about what's going on there. Whenever I'm subtracting a negative, it's nice to rewrite it as addition. So my numerator is still -8. My denominator, -2 plus 7. So I was in debt $2, and then I earned $7, so now I have $5. So there's my answer. My slope is -8 over 5, or -8/5. Remember, when you have a negative sign in a fraction, you can put it in the numerator or the denominator or out front, and the value is always the same as long as there's just one negative sign. So I could write it this way or this way, although it's probably less common to see it with the negative sign in the denominator, or we'll often see it this way with the negative sign right out in front of the fraction bar like that. So any of those would be great ways to say what your answer is. There's the slope. Okay, the next thing we want to talk about in this question is to say, based on the slope, do we know if this line is increasing, decreasing, horizontal, or vertical? And we notice our slope is negative. It has a negative sign out front, so the slope of the line is negative. So this line is decreasing, meaning it's going downhill. If we were to sketch it out from left to right, it would look something like that. It would look downhill. If you were a person standing on that line, walking from left to right, you'd have to be walking downhill. So anytime we see a negative sign, a single negative sign in our slope, we know it's a decreasing line.